Imagine this scenario. You're building an application and you need an API key to connect to a service, a database password, or a storage account key. So you drop it right into your code, maybe in a config file or an environment variable. It works and everything runs fine until you push that code to GitHub or share a notebook with a teammate. And just like that, your secret isn't so secret anymore. If that code falls into the wrong hands, your entire system is exposed. Now, Azure Key Vault is the tool that fixes that problem. It gives you a secure place to store secrets so they never end up in your code. But here's the thing most people get wrong. Just having a key vault doesn't automatically make you secure. The way you set it up, control access, and assign permissions matters just as much. By the end of this episode, you'll know what Key Vault actually is, what you can store in it, how access works, and the single biggest mistake that could leave your secrets exposed. All in plain English, no jargon, just the nuggets you need. So what exactly is Azure Key Vault? What is Azure Key Vault? Here's the simplest definition. Azure Key Vault is a cloud-based digital safe for your secrets. It's a managed service from Microsoft for storing API keys, database passwords, connection strings, encryption keys, and certificates in one central place. You don't have to worry about the infrastructure because Azure handles patching, uptime, and security. You just use it. Think of it like an office building. You've got workstations, meeting rooms, and filing cabinets, but somewhere in the basement there's a secure vault room where you keep the important stuff: master keys, cache, legal documents. Nobody walks in without permission and authentication, and every time someone opens the door, it gets logged. That's Key Vault, the secure room in the basement of your Azure architecture. Now contrast that with the old way. 20 years ago, if you needed a database password, you'd hard-code it in a config file, maybe in an environment variable, or worse, leave it in plain text in your source code. If someone got access to that server, they had everything. And if you needed to rotate that password, you had to update it everywhere. Every config file, every environment, every deployment. It was a nightmare. Key Vault changes all of that. Instead of scattering secrets across your code and config files, you store them in one central place. Your applications request them at runtime only when they need them. And because everything is centralized, you can rotate a secret in one place, and every application that uses it picks up the new value automatically with no code changes or redeployments. But here's the thing, Key Vault isn't just a password manager for your apps. It's a core security service. Every Azure service can integrate with it. App Service, Functions, AKS, Data Factory, Synapse, Logic Apps, DevOps pipelines all know how to talk to Key Vault. It becomes the backbone of your secure cloud architecture. And once you set it up correctly, you stop thinking about credential management entirely. What can you store? So now that you know what Key Vault is, let's talk about what you can actually put inside it. You've got three main categories: secrets, keys, and certificates. Each one does something different, and understanding the difference helps you use Key Vault the right way. Let's start with secrets. This is the most common thing people store. Secrets are connection strings, API keys, database passwords, storage account keys, basically all the everyday credentials your apps need to talk to other services. Instead of dropping them into your code or a config file, you put them in Key Vault. Your app fetches them at runtime and nobody ever sees them in plain text. Think of it like a locked drawer in your digital filing cabinet. Next up are keys. These are encryption keys for data at rest. If you're using customer-managed keys for Azure storage, SQL databases, or encrypting virtual machine disks, those keys can live in Key Vault. That gives you full control over who can use them and when. And if you need hardware-backed keys for compliance, the premium tier has you covered with HSM protection. Then we have certificates, TLS and SSL certificates for your web apps, APIs, and internal services. Key Vault can store them, manage their lifecycle, and even auto-renew them when they're close to expiring. That's a lifesaver for anyone who's ever had a certificate expire at 3 a.m. on a Sunday. Here's a real example. Imagine you've got a web app that needs a database connection string and an API key for a third-party service. The old way, you'd put both in your app settings, JSON file A. If that file ends up in your repository, anyone with access to the code can see your database credentials. With Key Vault, you store both values as secrets. Your app fetches them at startup, and they never appear in your source code. Need to rotate the database password? Update it in Key Vault. The app picks up the new value automatically on the next restart. No code changes, no redeployment. One thing that catches people off guard is that versioning is built in. When you update a secret, Key Vault doesn't overwrite the old value. It creates a new version. The old versions are preserved so you can roll back if something goes wrong. That's incredibly handy during incidents. You can quickly revert to a previous secret without having to remember what the old value was. You can store all three types, secrets, keys, and certificates, in the same vault. But best practice is to separate by environment. Have one vault for development, one for testing, one for production. This prevents someone from accidentally using a production secret in a dev environment, and it limits the blast radius if one vault gets compromised. But storing secrets is only half the story. The real question is who gets to access them, how access control works. Now let's talk about who gets in. Key Vault has two different ways to control access to what's inside, and the one you choose matters a lot. The first model is legacy access policies. This is the old way. You create policies directly on the vault, and you assign permissions to specific users or groups for specific types of data, secrets, keys, or certificates. The problem is, these policies are tied directly to the vault. If you have multiple vaults, you have to manage policies in each one separately. It doesn't scale well. Microsoft now recommends against using them because they have known security issues. They don't support privilege identity management, and they can create unexpected privilege escalation paths. The second model is Azure RBAC, Role-Based Access Control. This is the modern way. It uses Entra ID identities, and it's consistent with how you manage permissions everywhere else in Azure. If you already know how to give someone access to a storage account or a virtual machine, you already know how to give them access to Key Vault. Same system, same patterns. Here's the golden rule: least privilege. Give only the minimum access someone needs, nothing more. If someone only needs to read secrets, don't give them permission to create or delete them. If someone only needs to manage certificates, don't give them access to keys. Let me walk through the key roles. You've got Key Vault Reader. This lets someone list secrets but not read their values. Key Vault Secrets User. This lets someone actually read secret values. And Key Vault Secrets Officer. This lets someone create, update, and delete secrets. Notice the pattern. Each role is specific to the data inside the vault, not the vault itself. Now contrast that with the broad roles, owner, contributor, reader. These apply to the vault as a resource, not to the data inside it. An owner can delete the entire vault. A contributor can modify the vault's settings. But neither of these roles by themselves gives access to the secrets inside. That's a separate permission layer, and that's the key point. Access control is a layered cake. You need access to the vault itself, that's the first layer, and you need access to the data inside the vault, that's the second layer. Both must be granted separately. Most beginners only think about the first layer and forget the second. That's where the trouble starts. The number one security mistake. Here's the thing. Most people look at the Key Vault contributor role and think it's safe. They see the word contributor and assume they can manage the vault settings, but not touch the secrets inside. Microsoft's own documentation originally said exactly that. This role does not allow you to access secrets, keys, or certificates. Except that's not quite true. A user with the Key Vault contributor role can modify access policies on the vault. And if that vault still uses legacy access policies, which many do, they can simply grant themselves full read access to every secret, key, and certificate inside. No special exploit needed, no vulnerability to patch. It's just how the permissions work. Security researchers at Datadog proved this in 2024. They showed that contributor could escalate to full data access in any vault using legacy access policies. Microsoft's response was interesting. They said this isn't a vulnerability because contributors are designed to manage access policies, but they also updated the documentation to explicitly warn that the role can grant itself data plane access. So this isn't a bug in Key Vault itself, it's a configuration trap. And it catches even experienced teams because the role name sounds harmless. Contributor doesn't sound like someone who can read your database passwords, but in practice they can. Think about the risk. If an attacker compromises an account with the contributor role on your Key Vault, they don't need to break into the vault. They don't need to crack encryption. They just modify the access policy, give themselves read access, and silently exfiltrate every secret you've stored. Connection strings, API keys, certificates, all of it. And because access policy changes are normal administrative activity, it might not trigger any alerts. So what's the fix? First, use Azure RBAC for data plane access instead of legacy access policies. RBAC separates the management of the vault from the data inside it. Second, never give the Key Vault contributor role to anyone who doesn't absolutely need it. Third, if you already have users with that role, audit them today. Replace contributor with more specific roles like Key Vault Secrets User or Key Vault Secrets Officer. There's a second mistake that compounds this one: putting all your secrets in a single vault. If you have one vault for everything, dev, test, staging, production, all your applications, and that vault gets compromised, everything is exposed. It's a single point of failure. We'll talk more about multi-vault strategy in a bit, but the principle is simple. Don't put all your eggs in one basket, especially when that basket holds the keys to your entire infrastructure. Managed identity, the gold standard. So how do you do this right? Let's talk about the best way to access Key Vault. There's a fundamental problem. To get credentials from Key Vault, your application needs to authenticate itself. But to authenticate, it needs credentials. Where do you store the credentials your app uses to get credentials? It's a chicken and egg problem. The old answer was a service principal with a client secret. But that client secret has to live somewhere, maybe in a config file, maybe in environment variables, maybe in a deployment pipeline. And now you're back to the same problem. You've just moved the secret somewhere else. Managed identity solves this completely. Here's how it works. When you enable managed identity on an Azure resource, say a web app, a function, or a virtual machine, Azure automatically creates an identity for that resource in Entra ID. That identity is managed entirely by Azure. No credentials to create, no secrets to rotate, nothing to store. The resource just has an identity that Azure knows about. There are two types. System-assigned managed identity is tied to one specific resource. If you delete the resource, the identity goes away too. They share a lifecycle, which makes administration simple. User-assigned managed identity is a standalone identity you can assign to multiple resources. It doesn't share a lifecycle with any of them, so it's useful when you need the same identity across several services. Here's what this looks like in practice. You have a web app that needs to read a database connection string from Key Vault. You enable system-assigned managed identity on the web app. Then you grant that identity the Key Vault secrets user role on your vault. That's it. No connection strings in the code, no client secrets in config files. The web app authenticates to Key Vault using its managed identity, and Azure handles all the credential management behind the scenes. This is the closest thing to credential-less authentication in Azure. It's a game changer for security because it eliminates the most common attack vector: stolen credentials. If there are no credentials to steal, there's nothing for an attacker to compromise. Let me give you a real-world example. Imagine a data pipeline in Synapse that needs to access a storage account. The old way, you'd store the storage account key in the pipeline configuration. If someone got access to that pipeline, they had the key. With managed identity, the Synapse workspace has an identity. That identity is granted access to Key Vault, where the storage account key is stored. The pipeline fetches the key at runtime, uses it, and never stores it anywhere. No keys in the code, no secrets in the pipeline configuration. When you combine managed identity with RBAC and least privilege, you get a secure foundation for any Azure workload. Your applications authenticate without credentials. They access only what they need, and every access is logged and auditable. It's the pattern Microsoft recommends for almost every scenario. Once you start using it, you'll wonder why you ever did it any other way. Cost and multi-vault strategy. So, let's talk about cost. This is where most people get surprised. How much does Azure Key Vault actually cost? The pricing model is simple. No per-secret storage fee. You don't pay for each password or API key you store. Instead, you pay per operation. For the standard tier, it's about 3 cents for every 10,000 operations. A get secret call counts as one operation, so does creating a secret or listing what's in the vault. For a typical small to medium application, that adds up to pennies per month. Literal pennies. Compare that to AWS Secrets Manager. They charge 40 cents per secret per month just to store it, plus extra fees for API calls. If you have 100 secrets, that's $40 a month before you even read one of them. With Azure Key Vault, 100 secrets with moderate usage might cost you 15 cents. The difference grows quickly at scale. Now, there is a premium tier. This adds HSM-backed keys for workloads that need the highest level of cryptographic assurance. Think financial transactions, healthcare data, government systems. The per operation cost is higher, around 15 cents per 10,000 operations for advanced key types, plus a monthly fee per HSM key. But for most applications, the standard tier is more than enough. Here's the cost surprise that catches people off guard. For a typical web app with a handful of secrets and a few thousand operations per month, Key Vault costs less than $1. You'll spend more on the coffee you drink while setting it up. But there's a strategy that matters more than cost: how many vaults you use. The smart approach is a multi-vault strategy. Use separate vaults for development, testing, staging, and production. This prevents the most common accident: someone running a test script that accidentally reads a production database because the connection string was in the same vault. When environments are separated, that mistake becomes impossible. You should also separate by business unit or compliance domain. If you handle payment card data, put those secrets in their own vault. General business workloads go in another, healthcare data in a third. This isn't about being difficult, it's about limiting blast radius. If one vault gets compromised, only the secrets in that vault are exposed. The rest of your infrastructure stays safe. And 2 built-in safety nets you should always enable. Soft delete means if someone deletes a secret, it's not gone permanently. It goes into a recoverable state for a retention period you choose, up to 90 days. Purge protection takes it a step further. Nobody can permanently delete the vault or its contents until that retention period expires. Together, they prevent the kind of accidental data loss that keeps security teams up at night. How it all connects. Let's tie all of this together and see how the pieces fit. Key Vault is not an island. It's the central nervous system for secrets in your Azure architecture. When you understand how the whole system flows, everything clicks into place. Here's what happens when an application needs a secret. The application requests it using its managed identity. That identity is already registered in Entra ID. Azure created it automatically when you enabled managed identity on the resource. Entra ID validates that the identity is legitimate, then passes the request to Key Vault. Key Vault checks the RBAC permissions you've assigned. If the identity has the right role, say Key Vault secrets user, the secret is returned. All of this happens in milliseconds. The application never sees a credential. It never stores a password. It just gets the value it needs. Now think about how many Azure services can plug into this. App Service, Functions, AKS, Data Factory, Synapse, Logic Apps, DevOps pipelines. They all know how to talk to Key Vault. You can configure a web app to reference a secret directly in its application settings. You can set up a Data Factory pipeline to fetch a storage account key from Key Vault at runtime. You can configure a Kubernetes cluster to pull secrets using the Key Vault CSI driver. Every service integrates the same way, using the same identity system, the same RBAC roles, the same audit logging. The CI/CD pattern is especially powerful. Your pipelines fetch secrets from Key Vault at deploy time. They never store them in pipeline variables or repository secrets. If you need to rotate a database password, you update it in Key Vault. The next time your pipeline runs, it picks up the new value automatically. No pipeline changes, no code changes, no redeployments. Here's the thing that makes it all click. Once you set up Key Vault with managed identity and RBAC, you stop thinking about credential management entirely. Your applications just work. Secrets get rotated without anyone noticing. Certificates renew without midnight emergencies. The system handles it all in the background. This is the security posture that matters. Identity is the perimeter, not the network. It doesn't matter if someone is inside your virtual network or outside it. What matters is whether they have a valid identity with the right permissions. Key Vault enforces this by design. Every access request goes through Entra ID authentication and RBAC authorization regardless of where the request comes from. And everything is logged, every secret read, every key operation, every certificate retrieval. You can see who accessed what and when. If something looks suspicious, you have the data to investigate. This is critical for compliance, for incident response, and for just knowing what's happening in your environment. That's the beauty of it all. Key Vault, Entra ID, RBAC, and managed identity work together as a unified security framework. Each piece reinforces the others. And when they're all set up correctly, you have a credential management system that's both more secure and simpler to operate than anything you could build yourself. Actionable takeaways. So what should you actually do right now? Let's turn this knowledge into action. Here are the things you can tackle this week. Start with your permission model. Open your Key Vault in the portal, go to Access Configuration and check what it says. If you see Vault Access Policy, that's the old way. You want Azure Role-Based Access Control instead. The migration is simple. Switch the permission model and assign RBAC roles to the same people who already had access policies. Do it today. Microsoft recommends it, and the research we talked about showed exactly why. Next, audit any accounts holding the Key Vault contributor role. Open the IAM blade on your vault and look at who has contributor access. Every person with that role needs a good reason. Most of the time, they don't. Replace contributor with something more specific. If someone only needs to read secrets, give them Key Vault Secrets User. If they need to manage secrets, use Key Vault Secrets Officer. The goal is to close that escalation path completely. Then take advantage of managed identity. Any Azure service that needs access to Key Vault should use it. If you have a web app, a function, a data factory, or a virtual machine that's still using a service principal with a client secret, switch to managed identity. It's simpler, more secure, and it solves the chicken and egg problem we covered. Azure handles the credential management for you behind the scenes. One more thing, enable soft delete and purge protection on every vault. Soft delete is on by default for new vaults, but purge protection is not. Turn it on. That setting prevents anyone from permanently deleting a vault or its contents during the retention period. It saved more than one team from a disastrous mistake. Here's your call to action. Look at your current secret management approach. Find one secret that's still sitting in a config file, an environment variable, or hard-coded in code. Move it to Key Vault this week. Just one. Once you see how simple it is, you'll want to move the rest. Security isn't a one-time setup, it's a practice. Key Vault makes that practice easier, but only when you use it correctly. The tools are there, the patterns are proven, now it's up to you to implement them. That's the system. Key Vault is your digital safe, but it's only as secure as the access controls you put around it. Start with the audit I just described. Check your permission model, check your contributor assignments, and move one secret into a vault this week. Subscribe for more cloud security nuggets in plain English, and share this with someone who's still storing secrets in config files.